All right, so let's talk about the unit circle. Maybe a while since you've seen the unit circle or done anything with it. When I first realized that this was the case, it was kind of mind-blowing to me, very eye-opening, and so I want to go over it with you guys. Definitely want to point out the fact that, again, all we're looking at here is an XY coordinate plane, right? I got my Y coordinate there, and then here's my X going right through the middle. This is the X plane, this is the Y plane, or the X axis, Y axis. And all I'm looking at when I say unit circle is a circuit, or sorry, not a circuit. I just love circuits so much. A circle with radius 1, right? So the radius here is 1. Let me get this guy out. At all times on the circle, of course, the radius doesn't change. So at any given point, I have a radius of 1. That's why it's called a unit circle, okay? But what's important to note is that all the unit circle is describing is it's describing the x, y coordinates and the polar coordinates for any rotation. Let me grab a vector here of a vector of length 1 rotating in a circular pattern, right? If I rotate my vector 45 degrees, right? My length is still 1, of course, that hasn't changed. My angle here is 45 degrees. And my x, y coordinates are root 2 over 2, root 2 over 2. Basically means that if I were to look at the height, the y height right here, it would be root 2 over 2. If I were to look at the x right here, how far has it gone from the, in the x direction? That would also be root 2 over 2. That's what this tells us. It tells me the x and the y coordinate of this point right here. Okay, hopefully that makes sense. Now if I go around, let's go to another one. Let's pick a different color. Let's go to blue. And let's say I'm over here now at minus 135. Now I've gone 135 degrees. Or I think I said minus 135. I'm 135 degrees from the x-axis, so that would be my angle. Again, my length is still 1. I'm on the unit circle. So if I wanted to represent this point in polar, I would write 1 angle 135, right? Just like that. But if I want to write it in x, y terms, my x coordinate, in this case, now I'm on the negative x-axis, you can see, is going to be negative root 2 over 2. And my y-axis is still root 2 over 2, which is exactly what I see. Okay? And so this is what the unit circle is describing. If I go around the unit circle, I can just look at any given point on the circle, and not only do I have its xy coordinates, but I also have its angle and its magnitude, because that we know the magnitude of every single vector on the unit circle is just a length of 1, because the radius of the unit circle is 1. Okay, and so when I'm looking at this point or this point, we can see, right, I'm at negative 1 in the x direction, and I'm at 0 in the y direction. I'm at 1 in the x direction, I'm at 0 in the y direction. Okay, so if you already knew this, that is fantastic. If you didn't, now you do. And the angles, here that are in radians rather than in degrees. So we know that one full rotation around the circle is equal to 360 degrees. It's also equal to 2 pi radians, which is another unit for rotation that we use in engineering. We know that when we look at the circumference of a circle, let me just draw a nicer little circle here. When we look at the circumference of a circle, that circumference, basically the distance that I could go around the circle, is equal to pi times the diameter, right? C is equal to pi d if this is my diameter, right? And so if I have, I'm just going to go ahead and end this video here. This is probably getting a little bit long, so let me just go ahead and call it. And in the next video, we'll talk a little bit more about the unit circle.